All right, in this video, this one's gonna be pretty short. This one's just gonna go over page 11, and then I'm gonna save the pages 12 through 14 for the next video. So in this one, we're just gonna talk about where your equations come from. So your universal wave equations, so we go back to one of our first units. We know that velocity, let me turn my pen back on. My velocity equals displacement over time. Okay, but now we're dealing with waves. So displacement would technically be your wavelength, okay, over your time for one wave, which is called your period. Okay, so that is our first equation right there. So V equals wavelength over T. Okay, so that is equation number one. Now, if you need something, like if you need T or something like that, so remember we have these T equals 1 over frequency, or frequency equals 1 over T. So don't forget those are there, because there may be some questions where it's just like, what's my frequency? And if I give you period, all you gotta do is 1 over period, and you're good to go. Okay, so if 1 over T equals frequency, so that basically looks like that right there. There's like a little imaginary 1 right here, 1 over T. That means what I can do is I can get rid of that and put frequency in. So let me clear this up. Okay, so I can say that velocity is also equal to wavelength times frequency. So there's equation number 2. Okay, now typically when you see the V, okay, that stands for velocity. Usually when we use velocity or the V, that means that is a mechanical wave. Okay, meaning that if it has different mediums, so it has to have a material medium. Okay, so remember, a mechanical wave is something that needs a material medium. So that means material mediums have different velocities. Like if you had sound and water versus air, you're gonna have different velocities based on the medium. Okay, but the wave we've also been talking about is electromagnetic. So remember, electromagnetic waves are things like your radio, microwaves, okay, infrared, visible light, which is your Roy G. Biv. Okay, then you have UV, and then X-ray, and gamma. Okay, so I would really make sure I know those, because those all have a different velocity compared to mechanical wave. Okay, mechanical waves are a lot slower. Okay, electromagnetic waves move at the speed of light. Okay, so all of them move at the speed of light. So radio and gamma have the exact same speed. The only thing that makes them more powerful than the other is the different frequencies and wavelengths. So they all travel at the speed of light, and we will give you this value. The speed of light is c equals 3.0 times 10 to the 8th meters per second. So you can also say that c equals frequency times wavelength. So there's your kind of third equation. These two are basically the same. Okay, the only reason we're putting c there now is because when you're dealing with these electromagnetic waves, their velocity never changes. So that's why we put a c there, because it's always constant. It's always 3.0 times 10 to the 8th. Okay, versus the v's up here in the first equations, those could be anything. It could be sound, it could be a tone, something like that, or it could be sound and water, sound and air. So velocities can change a lot, okay, when it's a material medium. But when you're dealing with electromagnetic, their velocities will never change. Now, units. We need to make sure you're good on units. Okay, so velocity, usually everybody's pretty good at this. Velocity is meters per second. Okay, wavelength. Okay, length would have to be meters. Okay, dead giveaways, if you just told me velocity is meters per second, and I asked you, well, what's your distance? It would have to be meters, because you just told me velocity was meters per second. Now, your frequency is going to be hertz, so Hz, and then your period or time is going to be seconds. Okay, so make sure you know those, because one, you have to be able to read them in a problem and know what they are, and two, when you write out your answer, you need to give us the units as well. So number one, a water wave is propagating at the rate of 10 meters per second. So remember, propagating just means a movement of a wave through a medium, so it's just a fancy word for that. So I did give you velocity right here. Now its wavelength is 122.5 centimeters, so that's your wavelength, but I can't have centimeters, so all you gotta do is just divide that by 100, and that'll fix that, and put it in meters, and you're looking for frequency. So I'm gonna say, which equation has all three of those? V equals wavelength times frequency. Okay, so 10.9 equals my wavelength. So 122.5 divided by 100 is 1.225. And frequency we don't know. So divide both sides by 1.225. You get a frequency of 8.9 hertz. Number two, calculate the wavelength of 103.3 FM waves. So if I say FM, everybody's going to tell you, well, that's a radio wave. Okay, so a radio wave is a part, let me switch colors real quick. Radio waves is right here. Okay, it is a part of your electromagnetic scale. So that is a dead giveaway that you're going to use C equals 3.0 times 10 to the 8th as your velocity. Okay, now it says calculate the wavelength, so we're looking for lambda, upside down y, and 103.3 FM, that is a frequency. So if I was looking for equations, I know I'm probably going to use this, C equals frequency times wavelength. Okay, so you'd have to see, well, they mentioned C, and they're looking for wavelength. The only thing that's left is frequency. So this is your frequency right here. Now, you'll see this more in the next couple of pages. We'll tell you this, okay? It was probably is poorly worded here. Is all of your radio stations, okay? Radio stations are in megahertz. Okay, megahertz it's a lot more than just a hertz. Okay, so a megahertz is 10 to the 6th power. So that means 1 megahertz is 1 times 10 to the 6th hertz. Okay, so all we gotta do to fix that 103.3 is just add the times 10 to the 6th on the end of it. And we'll do a lot more of this in the next few pages on the practice sheet. So if you're getting kind of confused on this, on the next video, you'll see a lot more. Okay, so C is gonna be 3.0 times 10 to the 8th. Frequency, that is going to be 103.3 times 10 to the 6th. All you got to do is add that on the end. You don't need to change the decimal at all. Just add that on there. Okay, and then wavelength, we don't know. Now be careful with this. What I'm doing is I'm still seeing students that are trying to solve for these. Okay, even though it says 3 times 10 to the 8th, okay, and you type that in the calculator, it's still just going to give you, what it's probably going to do is either going to give you the exact same thing, or it's going to give you 3 with a bunch of zeros on it. All it did was convert it back to normal notation. It didn't solve for anything. It just converted it back to standard notation. So don't worry about trying to solve those, because those are technically just one number. It's just instead of writing out all those zeros, we just put it in scientific notation. So take 3.0 times 10 to the 8th and divide it by 103.3 times 10 to the 6th. Make sure you're using parentheses in your calculator. I'm still seeing a lot of students that forget the parentheses. And they're doing the math right, but when they go to check the key, they're like, what the heck happened? Well, if you didn't put parentheses there, your calculator gets confused and doesn't know what to do first, and so your order of operations is way off. Okay, so make sure you use parentheses. So you should get a nice simple wavelength of 2.9 meters if you did it correctly. Now, we'll do a lot more practice in the next video. This was just more of a simple video, kind of get you started.